This is 5.2 Sum and Difference Formulas, Day 2. Now, the first page here is just a reiteration of the formulas that we've been using lately. Cosine, sine, and tangent in terms of adding and subtracting different angles together. So the first page is, suppose that the sine of theta equals 4 over 5. Now, that would mean that you would be working on a triangle in quadrant 2 that had an opposite side from the central angle that's 4 and a hypotenuse length that's 5. So what would that look like? Well, here's quadrant 2 rotated around and over to here. So somewhere in quadrant 2 exists this triangle where the hypotenuse is 5. And here's your central angle right here. It's the one inside the triangle, centered at the origin. And the opposite side from there would be 4. What would the adjacent be? Well, that's a good question. If you use Pythagoras, you could say that leg squared, I'm going to call it x because it's our horizontal side, x squared, leg squared plus leg squared equals hypotenuse squared. So x squared plus 16 equals 25. Subtracting 16 on both sides gives you x squared equals 9. And then x equals either plus or minus 3. So if this is horizontally going left from the origin, it should be a negative 3, not a positive 3. That's a choice we make, and it's negative. So that's sine of alpha. This is the alpha symbol. Now beta exists in quadrant 1. So if we want to find what that is, that would be more like this. Okay? So here, the opposite would be 1 and the hypotenuse would be 2. So here's our central angle. Opposite from there would be here. They say that is 1. And hypotenuse here would be 2. And then again, we can use Pythagoras to help us find the other leg. Again, this leg is like the x side because it's the horizontal side. So I'm going to again call it the x. Leg squared plus leg squared equals hypotenuse squared. So that's x squared plus 1 equals 4. So x squared equals 3. Take the square root of both sides, you get plus or minus the square root of 3. Is this side positive root 3 or negative root 3? Well, if we go right from the origin, it's got to be positive. So our adjacent side is positive root 3. That is angle beta. So, if you want to find the cosine of alpha, you look at this triangle. Cosine is adjacent over hypotenuse, so that would be negative 3 over 5. However, if you want to find the cosine of beta, you look at this triangle. Again, cosine would be adjacent over hypotenuse, so that would be square root of 3 over 2. Cosine of alpha plus beta. Well, there's a formula for that, and that is from our sheet right here. If I have alpha plus beta, that's the same as x plus y. So cosine is what we're talking about. We've got cosine of x plus y, which is this formula right here. So I'm going to write that down, cosine of x plus y, but instead of x and y, I'm going to use alpha and beta. So it's going to be, cosine of alpha and beta would be equal to cosine of alpha times cosine of beta minus sine of alpha times sine of beta. Okay, well, cosine of alpha we have right here, that's negative 3/5. Cosine of beta we also have right here, square root of 3 over 2. So we just need to find the sine and the sine. Well, you know what? That's what our given information was. Sine of alpha was 4/5. Sine of beta was 1/2. So if I multiply here, I get negative 3 root 3. 5 times 2 is 10, minus 4 times 1 is 4, 5 times 2, 10. And then I put them all together because I have a common denominator of negative 3 root 3 minus 4 all over 10. Now I can do the same thing for the second fraction, or for the second value here. Sine of alpha plus beta is the same as the sine of x plus y. So I'm basically going to write down this formula, but instead of x, I'm going to use alpha, and instead of y, I'm going to use beta. So this one is sine of alpha times the cosine of beta plus the cosine of alpha times the sine of beta. Okay, we have all these numbers. Sine of alpha is 4/5. That was in our given. Cosine of beta we found over here. That's square root of 3/2. Cosine of alpha is right here. It's 4/5. I'm sorry, cosine of alpha is here. It's negative 3/5. There we go. And then sine of beta is right here. That's 1/2. So we multiply 3 times the square, or 4 times the square root of 3, and 5 times 2 is 10. Negative 3 times 1 is negative 3, and 5 times 2 is 10. And then we put it all together because we can add these with a common denominator to be 4√3 plus negative 3. You could also write that as 4√3 minus 3, all over 10.